Let's look at the next problem on our normal distribution practice. So this one, we're given a forest products company claims that the amount of usable lumber it harvested in its harvested trees has a mean of 172 cubic feet, a median of 175 cubic feet, and a standard deviation of 12.4 cubic feet. So we've been given extra information again. We don't need all of that. The key pieces of information we need are the mean and the standard deviation if we're being asked to make a normal distribution. If we were being asked to make something else, well, then we would need different information. All right, so we have usable lumber is the thing that we are tracking here. And so just so you're aware, you could label this at the bottom. But if you're like, oh, I don't have a lot of room down there, you could also put that label at the top. Call it a title. You're still telling me what type of numbers are being described in your normal distribution curve, and that's 100% okay. All right, in the middle, we have our mean, so that's 172, and then we're going to be adding one standard deviation to go above and then subtracting to go below. So 172 plus 12.4, and that gets us our next data point of 184.4 cubic feet, times it by 2 to get two standard deviations above, 196.8, and then one more to get a nice 3 standard deviations. That's just pretty much all of our data. And then we'll do the same thing below. I like to I start and I just minus those 3 standard deviations. So 1 standard below, 2 standard below, 3 standard deviations below, 134.8. Then I'll switch out that 3 to be 2 standard deviations below. And then last but not least, 1 standard deviation below, and I have my filled in completed normal distribution curve. And then we're just asked for 2 percentages. This is going to be straight into the Desmos normal distribution calculator. Now, some things to keep in mind. Notice I didn't delete out my function from the previous video. I just delete out my mean and standard deviation when I'm doing a number of these. Why am I refining the function? And so I'm going to just retype 172, comma. Do make sure you retype in the new mean and standard deviation, or you will be not looking at the right information. But I noticed this time I am looking at a line, not at the curve I want. So I'm going to zoom back into the sort of shape, that I want to see. All right, so we are asked what percentage of trees contain more than 180 cubic feet? So more than means that we're actually going to be putting that 108 in the min because we want everything above 180. And knowing that that's a little above 1 standard deviation, it should be less than 50%. And it is. It's only, it's about 25.9%. Oops. It always surprises me how quickly the percents go down as we move away from the mean, which is a really key idea. Remember, it's 34% of the data between 1 standard deviation and the mean. So right here is 34%. That's a huge amount of the data. That's more than what you see in 1/2 of the inner quartile, like between the median and quartile 1 on a box plot. Just to give you a sense of the amount of data points in there. Um, it doesn't look it, but there is so little data out there in the wings of this. That's why we call them outliers. All right, the next one, we're doing a between. I love betweens because you really don't have to debate which way you're going to go. Because if I accidentally put 190, watch this, 190 in the min, and then I put 175 in the max, it tells me I've done something wrong. I can't enter it incorrectly. Sorry about that cough. So it tells me invalid limits. So the min should be less than the max. It lets me know I didn't type it correctly. And so I'm going in and typing it correctly now. And I get 33.1%. And we weren't really asked anything more than that. we were just asked for 2%. We didn't have to do any further conclusions with it. A little bit of practice using our normal distribution calculator. All right, let's move on to the next problem on this side. We are looking at the GPA of freshman biology majors at a certain university have approximately a normal distribution with their GPAs. The median is 2.8, the mean is 2.87, and the standard deviation is 0.34. So that mean and median are pretty close, but they're not exact. So we still want to use that mean, not the median. Standard deviations involve the mean, and normal distributions involve the mean also. And so we want to take that 2.87 GPA and we're going to add 0.34 to it to get one standard deviation above. Then I would times that by 2 to get 2 standard deviations above. And then I would times that by 3 to get 3 standard deviations above. And notice that no one really in this major has a 4.0 GPA. Okay, that's, might be realistic. Biology could be hard. I definitely was not a biology person. So 3 standard deviations below, a 185, though they're not passing. 2 standard deviations below is a 2.19, and 1 standard deviation below is a 2.53. What would be considered a normal range for the GPA of our freshman biology majors? So remember, with our normal range, we have our mean, and we go 2 standard deviations above, so 1, 2, and 3.55 would be sort of a high end. And then we go 2 standard deviations below that mean, and 2.19, and everything in between would be considered normal. Oh, I forgot to label my things, so we should GPA of fresh bio majors. So the low end here would be a 2.19 GPA, and the high end would be a 3.55. And even without my normal curve, I could calculate this. Like if I didn't have the drawing out, I personally like having the data display. I'm a very visual person, so it helps me to see the number line. But just in case you're like, oh, I just wanted the normal range without having to draw out the diagram, you could calculate that by taking your mean. So I would have, I'm going to just do it in a different color, the 2.87, and I would minus 2 times my standard deviation of 0.34, and I'd get my low end. And I could do the same thing on the high end. So I would take the mean and I'd add 2 standard deviations, which is basically what we did to build the normal distribution. But in case you didn't have to build the normal distribution, just so you know, you could still figure out part B. All right, now we're back to our percentages. Now, don't forget to change your mean and your standard deviation in the calculator. So 2.87 is very different than 172. And 0.34, notice I need to zoom in. I'm going to clear out my min and max. So I'm back sort of to square one. So what percentage of bio majors have a GPA above 3.5? I already know that's not going to be very many because 3.5 is pretty close here to that, 2 standard deviations above. It's not quite an outlier, but it's pretty close. So we're going to set that 3.5 as the max value. Or not max value, sorry. I was saying it and thinking it and then not the min value. So I shade everything above. And you'll notice it's not quite, it's more than 1%, but it's still not a lot of the data. It's only 3.2% of those bio majors have a GPA above 3.5. So it's very, very few. All right, students are thrown out of school. Ooh, how horrible. If their GPA falls below 2.0. Ooh. If there are 250 freshman biology majors, how many of them got thrown out of school? Okay, so key here is it first I need to figure out what percentage would I predict have below a 2.0 GPA. So this time we're going to put in the max value of a 2. Don't forget to clear out the min. And I see, okay, well that gives me 0.525%, or not percent, yeah, percent, sorry. So I wanted to have this percent of 250. So turn that back into my decimal, and I took a few extra decimal places with it. I'm going to multiply it by my total number of students, 0.00525 times 250, and I get 1.31. So between 1 and 2 students, probably closer to 1, I would take either answer. So we could say, between 1 to 2 students. So not actually that many. So it sounds like horrible. You're like, oh my goodness, they're throwing kids out of school. And then you actually do the prediction math and you're like, okay, it's just 1 or 2 kids who don't cut the major. All right, so we've gotten all the way through problem 4 in this worksheet. Hopefully by now in watching the videos, you're like, yeah, I totally get this. But if you need to stay tuned, there'll be one more video where I walk through the remaining problems.